Hey y'all, this is a quick video on section 1.4 where we're talking about function notation and how those relate to equations and maybe solutions. So here was a problem we did in class. We can see that here is a function was given to us. By function we mean that a formula was given to us, y is equal to f of x of this particular form. And it just so happened that that formula f of x, f for formula, is 2x squared plus 3. So we have two notations for functions. We can say f of x is equal to 2x squared plus 3, or an equivalent way of saying that is y is equal to 2x squared plus 3. Once you have the function notation, this notation right here though, we can ask questions like the one we did in class today. This notation says the function f evaluated at x is equal to 5. And f evaluated at 5 turned out to be 53, because we would take the 5, and wherever you see the x in the equation itself, you plug in 5. Then you do some arithmetic using order of operations. You do the multiplication first, the powers first, that gives you the 25. Then 2 times 25, do multiplication next, turns into 50. And then we do the addition last. 50 plus 3 is 53. Okay. One way we can check, so in the notation of 1, 2, and 1, 3, what we can say is that the value x is equal to 5, y is equal to 53, sometimes written as just 553, is a solution to the equation y is equal to 2x squared plus 3. So this is some of the terminology that we learned in a previous video. So one of the points of this video is to show you that Desmos also knows notation, function notation. So one could come over here, for example, and put f of x is equal to 2 times x squared plus 3. 2 times x squared plus 3. Right? And now that formula has a graph, as we'll talk about more later in this class. So when we talk about a solution to this equation, one can say, make the point 5, that's the x value, and the y value will be the function evaluated at 5. And one could create a label of that on the graph, and one can then see, if we zoom out some, right here, to zoom out quite a ways, there is 553. That is a solution to this particular equation, y is equal to 2 times x squared plus 3. Jason, there we go, 2 times x squared plus 3. And both in function notation, you get the same picture. In purple, y is equal to 2x squared plus 3, or 2x squared plus 3, f of x is equal to that. So we're saying the same thing, just representing it in one in function notation and one in function notation, that's the blue one, and then the purple one we're representing as an equation. But they're representing the same thing. 5, f of 5 is a point on the graph. It is also a solution of this equation right here. One could create a table of values if you wanted. Nice thing about a function, one can then just write f of x, where f of x is the formula that we already know. And if you put in 5 for x, the y value comes out to be 53. One can then put different values. One could put 3. There is another solution to the equation, 321, or one could put 0, for example, and there is one of our solutions at 0, 3. Okay, so that's what we were seeing over here. The problem was asking us to find f of 0. One would find f of 0 on paper by, this is the function evaluated at x is equal to 0. So we're going to look at this function, 2x squared plus 3, this formula, And then wherever you see the x, put in an x is equal to 0. That's what this f evaluated at 0 notation means. So then this would be 2 times 0 squared plus 3. Do the powers first. 0 squared is 0. Do the multiplication next. That 2 times 0 is 0. And then finally you can do the addition last. And that's why we are finding that the function evaluated at 0 is in fact equal to 3. And we can see that 0, 3 is a solution of this equation because this dot right here, 0, 3, appears as a point on the graph of the function. So all of the different notations are coming together, and this was just a quick video about function notation, solutions of equations, and tables of values again.